Welcome, everyone, to the Friday, April 22nd installment, the day one of three of the Cybersecurity with Python and the Microbit workshop. We have a slideshow with lots of links built in. And so you might end up wanting to refer back to some of it and follow a link that maybe you saw me follow. And so I am going to paste that link into the chat. And there it is. A few tips for using Zoom. The first is that let's have somebody mute themselves. We've got some background noise. Okay, thank you. So when I started displaying the slideshow, it may have pushed Zoom into full screen mode, and that can end up being difficult if you're trying to also work on writing or entering a script and you have only one screen available to you. So to get out of full screen mode, you can click this little view icon that you might see in the upper right of your Zoom. And when you do so, there will be a drop-down menu and you can exit full screen. Then you can resize the Zoom window as you like. Here's an example of the Zoom presentation on the left, and then the Microbit Python editor that we'll be using on the right. Some more tips for having this go well is first of all, if you have a lot of applications open, close those applications. If you have a lot of tabs open in Chrome, again, close as much as you can so that you only have, say, a Chrome browser open and your Zoom app open, and that'll really help make sure that that your computer doesn't act like it has a ghost in the machine at certain points while you're trying to follow along with this. Oh, and also in some cases, there's a little power usage, little battery icon in your system tray, and it's best for these to go ahead and click that and wind it up to maximum performance if you have that feature. With you today are me, Andy Lindsay. I'm an applications engineer at Parallax. Ari Alvarez, he's our company vice president, and Stephanie Lindsay, our product and documentation manager. Today, we're going to be really going over a lot of basics. The first half will probably be the basics of using the python.microbit.editor or Python microbit editor, and then also some scripting basics. And then after the break, we'll do some more scripting. And before we stop for the day, we'll set up the 2 microbit connection for as many people as possible, and we'll stay after to do some troubleshooting on that for any of you that have trouble. Normally, it's a classroom full of students, and they might pair off or work in groups of 3 or 4 on little microbit radio networks. But for us, we're going to try to connect 2 microbits to 1 computer and get them both running at the same time with 2 separate editors. It's a little tricky, but again, in the classroom, it's not like that. It'll be 1 microbit on 1 computer. Wednesday, we'll be looking at encryption quite a bit and how to use it against things like sniffing and brute force attacks. And then on Friday, we'll talk about malformed packet attacks, along with some discussion about the Cyberbot robot and how that can fit into cybersecurity in addition to the microbit, and also educator resources, upcoming workshops, how to purchase, Q&A, and wrap up. So that's what we'll be doing this week. And again, today we'll be working on using the editor, the basics of the programming language, and then some of the more computer sciencey stuff that ends up being a basis of some of the scripting that will be done on Wednesday to demonstrate cybersecurity attacks and defenses with the microbit network, radio networks. A little bit about myself. My background is in electronics engineering. I've been working for Parallax for over 20 years and have spent most of that time in some kind of facet of education, such as helping do parts of the Cyberbot robot from the design phase to the documentation phase. Likewise, I've set up some electronics lessons, and I've done that for other devices aside from the microbit as well. Parallax is a small business in Rocklin, California. That's just outside of Sacramento, and we've been in education since 1997. The main focus at Parallax has always been embedded electronics. So essentially, most devices that we work with these days have some circuits and some programmable brains in them. And those programmable brains usually take the form of microcontrollers, although more and more often full-blown computers are now appearing in these devices. But regardless, if you see a device that has a little display and some push buttons, it has a speaker to make noise, maybe some motor actuators or microwave emitters in the case of the microwave oven, or even your cell phone, there's microcontrollers inside all these common products. And then also we have microcontrollers and embedded electronics for use in inventions and student projects. Okay. Chip Gracie is Parallax chief inventor. He's made some really amazing things, and Ken Gracie, his brother, is the company CEO. One of the things that Chip invented back in the mid-90s was called the Basic Stamp microcontroller, and this pretty much changed everything for microcontroller in the hobby and education worlds, because this was the first device where you could easily plug it in, connect some circuits to it, and then use the basic programming language, which was the beginner language of the day, to get stuff done, to invent in a very rapid prototyping fashion. And also, it just made it approachable. And so students, or schools, pardon me, began to really take it up. And so we developed the Bobot robot way back then, and the Board of Education, which is this little prototyping area on top of it, and made various electronics and robotics curricula with it. And it became very popular. Fast forward 20 some odd years, and the easiest, most approachable microcontroller of this time is the microbit, the BBC microbit. The BBC made north of 1 million of these and distributed them to junior high school students in the UK, along with curriculum for them to follow along to learn some of the basics of microcontrollers, embedded devices, and so on. And this is a really fun link right here, this Make It Code It link. I'll go ahead and paste it to you. Copy. Okay, chat, paste, there you go. And when we go there, what it has is a bunch of really light activities to go through. And it follows a certain sequence that introduces some of the basics of writing scripts for anything or programming any device, but it does it with kind of an engaging microscopic cell phone-like device, that being the microbit. And so we start off with the most basic thing, which is really communication. And so here the microbit is showing a heart on a display. And I'll go ahead and follow one of these links shortly, but I'd like to talk first about how this is, first of all, it's nice as an icebreaker set of activities. And then secondly, there is some method to the madness in that here we're starting with communication. In this example, students write a script for the microbit that has a beating heart, which actually has two different shapes, a small heart and a large heart. And then that is repeatedly displayed with a loop. So we have communication and now repetition or looping. Later on, there's the emotion badge where you can press the A button and maybe get a smile, and the B button and maybe get a frown. And that way you can show your friends what your reaction is to, or that way students can show their friends what their reaction is to the latest joke or whatever they say. And this is an example of adding conditionals to the party. So we have now the ability to say in the script, if the A button is pressed, display a smile. Otherwise, if the B button is pressed, display a frown. So now we have communication, repetition, and conditionals. Moving down the list, and there's hopefully it's kind of showing that there's an element of fun to all this, that you can that students can play with dice or the magic 8-ball. There's graphical dice, and then my favorite one, which now we have also calculations added to the party, is the step counter. And so I'll go ahead and share that link with you, and we can try this one as part of the icebreaker for this workshop. Paste. Now, when you get to this page, there'll be introductory videos, and the coding guide is pretty graphic programming centric, but we will be using Python. And so again, it starts off with an introduction. It talks about how it works, both from the coding and the hardware standpoint inside the microbit. And then we get to the code it part. Now, it defaults to showing you the Microsoft Make Code version of the script that will count your steps. For those of you who are doing some of these lessons, the Python is where we want to start. This is a good warm up, or well, rather, this would be a few steps down the road where students will have tried some other examples first. And I'll go back up and just display the very first example to show you that the code is much more concise at this point. Two lines. And then after they've gone through and tried a bunch of these projects, we are up to now 6 execute, or well, a total of 6 lines. And so what I'd like to do is copy this and paste it into your chat. And then we'll have, ooh, that didn't look right. Sorry, something went wrong with the copy paste. It hasn't done that before. Let me just make sure, first of all, that I can get this into my microbit editor, python.microbit.org/v/3. And if I paste over this, okay, that worked. So now let me try pasting into here again. Yeah, that's not working out at all. Maybe it is. Okay, I'll try copying from here and pasting into the, no, it's completely scrambled. Not really sure what's going on there, but I think I can fix this by first pasting it into the microbit editor and then pasting it into, copying again, and then pasting it into, okay, that looks better. Well, I guess a recent update has kind of, will make this a little different for at least on my end. And at any rate, now you've got the Python script in your chat. And so the next thing to do is take that and paste it into the python.microbit.org/v/3 editor. I'll give you that address. So you've likely been there quite a few times already. And then what happens? Well, when we run this using the send to microbit button, and it's going to prompt us to, so I usually get really firm about lecturing students that when they hit the send to microbit button, it's going to prompt them, okay, you want to make sure that your USB cable is connecting the microbit to your computer. And then when you hit next, what this window is telling you is that it's going to prompt you that when you hit next, it's going to prompt you to, one, choose your microbit from a list, and there will be more than one microbit in that list as the workshop progresses. And then after choosing your microbit, hit connect. So when we hit next, oh geez, I didn't unplug my one of my microbits. Okay, so I'm going to unplug my microbit, and now I only have one there. I'll select it and hit connect. And apparently I was using this particular microbit with the maybe with make code earlier on, because it's doing its one-time loading the MicroPython microbit runtime into the microbit. So this first time loading the script takes a while, and then after that, the subsequent send to microbit button clicks will result in a really quick, rapid loading of the script into the microbit. Now, once the script is loaded, we'll be able to shake this microbit, and each time we shake it, we'll see the number of steps counted be updated on its display. So let's take a look now and see how that goes. So there's 1, 2, 3, 4, and so on. Can I get some thumbs up from those of you who got that to work? Oh, you guys are already all on top of it, I see. Excellent. Way to go, everyone. Okay. And so there is part of the make it, code it section of the microbit.org website, and how it can be used as a fun way to, first of all, be exposed to all kinds of different things you can do with the microbit, given that it has the ability to sense tilt and vibration. It has the ability to sense light, temperature, audio input. It can make sounds. It can sense push buttons, and it of course has a built-in display, a little touchpad, and then this edge connector is for either plugging into adapters or building circuits using alligator clips. Okay, good job so far, everyone. Do feel free to break in or chat a question. Either way is fine if you have any. So on the microbit scripting depth chart, the make it, code it that we just did is probably the closest to the surface. And then as we go further down in the depth, there's the Cyberbot robot tutorials, and then cybersecurity is a little bit deeper, and then the electronics is probably for high school students, say 10th grade and up. Now, this fun little thing right here is an installment of a microbit only workshop where we go through a lot of beginner topics. And so this slide has a link to the microbit for beginners workshop that we most recently did. And following this link, just to show you, it'll take us to the sign up, or the previously used to be the sign up page. And here we have a link to the YouTube recording. And then here we have a link to the Google Slides. So much like this one, these are the kinds of resources you'll have after the workshop is done. And so this is the kind of thing where you could follow along and watch the YouTube and follow the slides that are, or follow the links that are built into the slides as you go. A little bit more on resources. The student lessons are at learn.parallax.com. I'm using the Cyberbot instead of the pure microbit just because it provides a superset. And I'll go ahead and also go to the microbit only version of this. So what we did was cybersecurity happened with the microbit and the Cyberbot, but we noticed that there are a lot of activities where the microbit is used on its own. And so what we did is we called the microbit only activities and put them into a page that I'll get to in a second, but first I'll paste this one in. And so you can go to learn.parallax.com. And then here is the cybersecurity workshop or student resources. And I just pasted those in. So this is like the table of contents for a book. And so each of these is going to take you to a chapter. And so one of the chapters that we'll be looking at later on, probably start of Wednesday, is radio data. And here we have some activities for the students to go through, in this case, where they're using Python to send packets from one microbit that's transmitting to another microbit that's receiving. And in this case, what it's doing is a countdown where the sending microbit, you tell it where to count down, where to start counting down, and then what you want it to say after the countdown is done. But that is turned into data that is sent over the microbit wireless network to the receiver microbit, and then it does the counting down and the I'm done counting down message. And we'll try that later. But this is an example of one activity in a chapter, and then we have some other radio data packet sending and receiving activities, including expanding the amount of data that's sent and so on and so forth. Anyway, suffice to say, this is a chapter. Each chapter has a number of activities in them, and then those chapters are accessed through the table of contents, which is right here for the microbit only stuff. And did I paste that in? Yes, I did. Okay, so that should all be in your chat. And again, you can also get to it from various slides. There are also teacher resources. We'll be talking about this more on Friday. And between Wednesday and Friday, we'll have you, if you haven't already signed up at learn.parallax.com, we'll have you sign up, because let's see, would the wireless communication interfere with classroom wireless setups, or does the microbit require connections to the classroom wireless? That's a really good question, and the answer is it's all good. There's no interference with classroom wireless, and there's no special setups that are needed. That's one of the reasons we felt like it was so important to do this particular project, is because of the fact that it's an easy startup. It requires no participation from the school's IT. It's just, once you've got it up and running, the microbits are talking to each other. It's true that they're using the same frequency as Bluetooth, but there is no crosstalk between Bluetooth. And of course, Bluetooth also, there's some crossover with wireless. Again, there's no interference. It's just a nice little quiet network that is unto itself. And it also cannot get anywhere else and do damage to, since it has no access to the school's network, there's no way that any student could ever go spelunking in a place they're not supposed to. It's very self-contained. It's microbit to microbit only. Let's see here. All right. Yeah, thank you for asking. That's a really good question. So the teacher resources, which did I paste that in? Yeah, okay. So teacher resources, and then again, this is example is for the Cyberbot, and we'll show you where the cybersecurity stuff is within the Cyberbot. But notice that right now the assessment. So there's some general information for teachers up here, including like some standards alignment tools and a link to this slideshow if you want to harvest any of the slides to show to your students. And then there's assessment materials, but those are locked off. They're only for teachers. We make sure that anybody who joins is a teacher before we give them access to that. And again, we'll be looking at that on Friday. Okay, notice that I just closed all the other tabs on my slideshow, and that's to make sure my computer does not slow down as we're making our way through this workshop. Okay, so a few more resources. Here is the Cyberbot robot, and these are product pages. So previously I talked about the location defined student and teacher resources, and then there are also links to product pages or lists of products in case you're interested. So here's the Cyberbot robot. And then here is all things microbit. So this is where you could go to buy a microbit, for example, or a bunch of microbits for your classroom. So paste. And notice that we have lots of microbit kits and products, but right here is the bundle that those of you who did not already have microbits and want, oh no, this is the 10-pack of microbit modules that are just like the ones, or microbit Go kits that are just like the ones you received. It's called the Microbit Club Bundle. And then there should be a 1-pack somewhere down the way. Here's the Microbit Go bundle. So this is the one that we sent you 2 of them to attend this workshop. And it's got the microbit, the USB programming cable, batteries, battery holder, and some nice papers that are inserted that I wonder how many people actually read them. I have not yet read them myself. See, I have 2 full class sets of 42 Cyberbots. Would you suggest we use the microbit in the kit or buy separate microbits to do the cyber activities? Really, either way is fine. It depends on whether you want to, certainly if you want to have it going concurrently. For example, you'd have one class with robots and microbits in them, and then a separate class later in the day where they're using only the microbits and it's different students. Then I would recommend having a different set of microbits for that class, as in microbit only. If you have them running in units, which would be another way to do it, like for example, part of the semester would be spent on Cyberbot robots, and then maybe another class part of the semester would be spent with microbits only. Well, you could harvest the microbits from the Cyberbot robots at that point and teach it that way. So it really just depends on how you're using it and whether you need to have a separate set. Let's see here. Should we have 2 Go kits? Yes, you should have 2 Go kits or 2 microbits, really. You don't need 2 Go kits entirely. If you have microbits in your class already, just grab a couple of them and a couple of USB cables, and that should be fine. Let's see, each student gets issued their own Cyberbot instead of a textbook. That's cool. Because yeah, the textbook is definitely online and available to them. Okay, and then one last thing, the upcoming workshops category. So this is where you can find out what's next. And so here is a link to that. And just so you know, here we have some in-person events coming up, and then we'll be adding more online workshops as the season continues. This is the last online workshop for the spring season. And also here are past events. And so if you look at the past events tab, did I paste you guys this? Yes, I did. Notice that back in March, we did a Cyberbot robot workshop. And if you view the event, we have the YouTube sessions right up top. And then in the YouTube video, if you click more in the description below, you will see the link to the slideshow that goes with it. So that's another way to get to older material. And so again, going back to past events and scrolling down, and you'll see that we have a 2-hour beginner workshop. This is the one that I talked about earlier. And then going back further, there's another microbit for beginners workshop, and so on and so forth. And you can definitely find some good material there with the YouTube and the slides. Just a side note, with cybersecurity, we so often think about network security, like the school networks and having your computer infected or your phone infected. But there are also opportunities for Internet of Things devices to be infected. And that applies to both military and commercial, industrial, as well as just personal information protection. And so becoming familiar with how one microbit could infect another microbit or have unauthorized monitoring of communication provides a microcosm for these kind of cyber attacks that we've seen on the news. And each one of these, if you click the picture, it has a link to the source material if you're interested in reading about that. And now we're going to move into the lessons, and we'll go through some of the beginner stuff today. And again, there's cybersecurity. A superset of it is in the Cyberbot tutorial series. And then the cybersecurity tutorial series is a microbit only subset where the Cyberbot robot is not required. Each of these, regardless of whether you're using the Cyberbot robot or the microbit on its own, this was designed as an enhancement to a computer science curriculum where we've seen cybersecurity being added to most computer science classes. And so we have up top, we have a whole lot of lessons on scripting that fall under the computer science umbrella. And then after students have completed those, then they can continue on to the cybersecurity lessons and get used to radio networking with their microbit, encrypting their data, and then using encryption as a tool to protect from various attacks. So we did some of this already, the microbit Python editor basics. And this is looking like a slide that maybe I accidentally did not. Oh no, this is the right spot. Okay. So in your homework, hopefully this will look familiar. So this is where we connected the microbit, watched the video, and then followed the steps that the video showed to connect the microbit and make sure we could load a script into the microbit. So this was homework. And then we got the hello and the heart display. Now, again, I'm inside a chapter here. I'll go ahead and paste you. Actually, I'll go back one page and paste you the cover link. And so the first page talks about the equipment you need, which is just the microbit, a computer with a USB port and a USB cable. And if your computer only has USB-C, then you'll want a USB-C to A adapter as well. And then again, this was part of the homework. And this can go page by page. So you can navigate it through the table of contents, like this is the next page. Or you can scroll to the bottom and advance pages this way. And you can also even use the left or right arrows on your keyboard. So I just hit the left arrow to advance from, so here we are in the main activity that you tried out, and I could click try this, make changes. And see, it shows right now we're on Flash scripts with Python editor, and then try this, make changes is the next page. Now I can click here, or I can click at that bottom right thing for page navigation, or I can just hit the right arrow. And when I do, we see that now we're in the try this, make changes to the script part. Now, for that matter, I think I would like to have you try changing the script. So we have, if I go ahead and see, if I reload this, do I get the default script? No, I don't. python.microbit.org/v/3. Okay, so now we're back to the default script. And so what we'll do is we'll take heart and change it to happy. And change hello to hi and make sure that we can get that as a modified script, which I'm pasting to you now. Send to everyone, paste. And when we send that to the microbit, we should see hi and then a heart or a happy face. I forgot the exclamation point as the lesson has it. And notice that in both of these, we're asking the students to put their hands on the keyboard. They can't copy and paste any of that. So give that a try and make sure you've got the hi and the smiley face. Now for this one, this talks about saving and editing scripts. And so we have a modified script with there we have the exclamation point. I'll paste in the corrected one. There we go. All right, and so with this script, we want to name it and save it. So that's basically what's happening in this activity. And again, there's a video about it and then step-by-step instructions on how to save. To save time, I'll just go through this and just show you what it looks like. So once we've sent it to the microbit, tested it, and make sure it works, there was also an optional, hey, simulate this to make sure it's going to do what you think it's supposed to. And so there's the simulation. Pardon me. So here's the simulation. And then here it is on the actual microbit, matching up nicely. And so we've tested it. We like our script, so we want to save it. So the first step is to give it a name. I need to remind myself what name we gave it. Happy image high text. So to name your project, simply click the untitled project button, and then we can type in happy. I like to separate it with dashes, but it's not required. Okay, so naming the text is not everything. In order to save it, first you have to give it a name, then you have to hit the save button. And it's going to tell you, hey, that project is saved and it's in your downloads. And then I don't know if you noticed, but there was also, it showed, hey, in the downloads, here is happy image high text. Bear with me a second. I'm correcting a preparation step that I missed. Okay. So it's telling you to open your downloads folder. So you can do that one of several ways. First is you can click the downloads button in your browser. It's going to be in the upper right. And then when you point at the file of interest, it'll have a little folder icon that you can click. And then that will open your file browser. That's Windows Explorer or Mac Finder or the Chrome Files app. And here we have happy image high text. And so here it is in downloads. Oopsie. And of course, students will also tend to just open their Files app and then go to downloads. And then they'll see the same file. Great, so that's that. Now we've saved it. Now let's change it again. I'll change it back to heart and hello. And we can save that as, say, default script. So again, you have to name it and then save it. And now we're going to have 2 hex files that end in .hex in our downloads. Okay, so we have this one, and it has heart and hello. And to get to the other script, simply hit open. It will plop you in the downloads folder by default. And if you have students storing their files elsewhere, yes, they will have to navigate to whatever little network spot or local spot they have to store their files. So we had default script open, which is showing hello and heart. And so I'll choose happy image high text and click open. And then we're back to happy image high text. And that's how to save and reopen your work. I spend some extra time on this point, both in the tutorials and here, because it's not at all like Microsoft Office where you're just hitting save and then opening. There's a little trick. You have to know that it's going to appear in your downloads and that you want to make sure to update the name before you save it. Now, if you don't update the name, that's actually okay too. For example, if you have a project that's taking a lot of steps and you and let's say that we modify this to say hi again, we can save that and then look at it in our Windows Explorer, and we'll see that we have happy image high text and then happy image high text appended with the number 1. And so that's a nice thing for if you're doing multiple development steps in a more complex script. Okay. How are we doing so far? Everybody okay? All right, thank you for the thumbs up. See, can you explain how kids might do this on a Chromebook? They don't always have download folders. I haven't ever seen a Chromebook without download folders. Okay. I thought, I mean, I've seen it with students not having download folders. Chromebook, yeah, I mean, Chromebooks should always have a download folder. So if they don't have a download folder and they're storing it somewhere else, like, let's see. Okay, so it goes to the root of your hardware. So let's see here. Let's see, I'm going to make a new folder here. New folder, my scripts. Okay. Yes, go ahead.
The suggestion has been made to point them to a folder on Google Drive as well.
Okay, now for a folder on Google Drive, it won't necessarily save or open directly there. It has to be downloaded and then copied to Google Drive, to my knowledge.
No, you can't go directly onto the Google Drive. I just backed up what I was doing. So you can either download directly onto your hardware without using your Google Drive. You have a certain amount of memory available on your Chromebook. Or you have the option to go onto your Google Drive and you choose which folder to directly download it to. And then after, from your microbit Python editor, you can reopen it. You just have to search for it.
So I take it then that in the Google Files app, you would see the Google Drive somewhere along the left here as you're browsing for your files. Is that right?
Yeah, on my side, I see both the hardware part, if you want. There's a section we say downloads, that's the hardware.
Yes.
And then there's the Google Drive, all my shared drives and all that.
So it'd be kind of akin to me choosing network, for example.
Not
It would
really.
be you'd have like a little section with Google Drive. It's just, you know, basically it's split up into sections, and I'm just choosing, I'm finding the Google Drive along the left, and then you can save it and reopen it from there. That's really awesome. I did not know that that was now available.
Yeah, it's been available for a while, but if you don't have Chromebooks, you won't know
that. Yeah,
Thank you.
so thank you for that. All righty. Let's see here. I just want to mention that there's also editor controls and a side panel. So a few things that you might want to know are that you have little buttons here to collapse and reopen your simulator on the right, and then your side panel on the left. And the left side panel has some really useful things. For example, if you wanted to possibly do something different with the display, it's got some nice ideas here, and you can even drag and drop these into your script. There's also some ideas, of which, like the step counter appears prominently in the ideas of things to try. And then the API, which is essentially the actual programmer's reference for something like display, is right here. And it goes into the detail of setting a pixel, of clearing the display, showing an image. There's all the different options of things you can do. And so that's found in the API. So the documentation is nicely built into the microbit editor. Then there's an important thing. Oh yeah, we all did this, right? Can I get some thumbs up on this, that we did this for homework? Okay, perfect. And so I just want to point out that if you say hi with display.scroll, you can also print hi. I'll leave 2 exclamation points on the print hi. So you can still rerun this, and we still see the hi in the display, but we can do show serial. And this doesn't always work so great the first time around. I've noticed that I have to open the show serial and then hit send to microbit again, and even repeat it a couple of times before I actually see the hi. And another thing that may be happening here is that, come on, wake up, serial monitor. Oh, there we go. So I had to this time hit hide serial and then show serial. And then I started getting the loop of hi messages. Okay, so that's it for the editor. And I think this is a good time to take a quick break. Everybody can get up and stretch their legs. It is 2 minutes before the hour. And so we'll go ahead and restart at 5 minutes after the hour. And anybody who wants to stick around and ask questions, we'll go ahead and turn off the recording. And then I might actually talk about some of the questions that came up after we turn the recording back on. Let's see, I see here. Okay, yeah, so we'll go ahead and reconvene at 5 minutes past the hour. It's currently again, just under 2 minutes before the hour. All right, welcome back everyone from the break. We just talked about using, well, we did some introductions and then talked about using the new version 3 microbit Python editor and some of its features. And so now we'll go on to just take a quick look at how the language is introduced. Before I do that, I want to mention that there's a reset button, so you can physically restart a program by pressing and releasing this reset button on the back of the microbit right next to its USB socket. And then this is where, especially for those of you who are concerned because you don't already know how to program in Python, this is going to be a really good starting point for you. Of course, studying the Python examples in the Make It Code It site is a good start, but this really takes you into the basics of writing Python scripts. And so here is the chapter, the chapter cover page for writing microbit programs. And like the Make It Code It site, we have it split up into communication, recollection, calculation, decisions, and repetitions. And so again, that's how we have the basics of writing programs or scripts set up. And then we've got some application examples, those being the push buttons. We also talk about constants and comments and writing functions and global versus local variables. And that kind of gives students especially a good basis for moving on to the Cyberbot robot, if that's the direction they're going. It also gives them a basis for the cybersecurity stuff, but they're going to need more for that. So let's just take a look at one of these examples. And again, if you're new to Python, the best way to make this work is to take your tutorial and set it side by side with your Python microbit editor. And then you can essentially go through and read the material just as the student would do. And then once you get, and again, this is for those of you who are completely new to Python scripting. The thing to avoid is what we've been doing with copying and pasting out of the Zoom chat in this case. What you'd want to do here is actually, read the explanation, follow the instructions, which are going to tell you to enter the script. And so just hand type it. It's so important to do that as you're getting used to learning a new computer language. And so here we are with that. And what this gives you, and if you can get your students to do this, what this gives both you and your students the opportunity to do is have this percolate into your mind. You're thinking about as you're copying it, okay, well, what is display.scrolling really do? Questions will come up and you'll end up experimenting and change hello to, test message or whatever. And each time you make a change and then test it out, it's going to, oh, I saved it. I meant to send it to the microbit. And it's not appearing again. Let's see if showing and hiding serial gets it to. This may be because I'm on Zoom, and so there's a certain amount of computer resources that are I'm going to try for that. Oh. Let's try again. Send to microbit. Oh, I'm sorry, it's display.scrolling it. The reason I can't see it here in this window is because I didn't use print. Send to microbit. Okay, so we're using print, and we now see test message in the serial monitor. But you can change that to display.scroll. And send it to the microbit again. And I'll go ahead and make use of that reset button. Press and release. And then we can see the test message displayed on the LED matrix display. Sorry, I jumped away from that a little quickly. Okay. So let's see here. I think what I'll do is show you guys a mashup of all the lessons. So essentially, students are going to go through and they're going to follow along. And so scrolling text is just one example, but it's an example of communicate. And we talk about it a little bit more deeply, and we get them to use some of the features in display.scroll. And then we have them try out the pre-made images. And we have them try out custom images by placing, by setting particular pixels. Then they move on to remembering. And so what I'll do or what I did rather was, I took just the very first script from each of these activities and put them in a little program that we can try out. Okay, so in slide 29, here is the entire script. Again, I need to paste it into my all right, so let's go ahead and paste you guys this. Or actually, first I'll show you how to run and test it. This, instead of using display.scroll, it's using print. So it should all appear in the serial monitor. And so the first thing it's going to do is tell you to press enter to continue. So it displays hello, which is right here. And then it tells you press enter to continue. And then we'll move on to the remember portion. Okay, so I'm pasting it in, and have you go ahead and try it. Paste, boom. I'm not sure why, but my computer keeps on moving back to another screen. Huh. Duplicate. So weird. Noticing some different things about Chrome from the last time I did this. So again, these are excerpts from the beginning of each of those activities. So we start with printing hello and then inputting, which if you press enter, it'll allow it to continue. You can also say, well, I'll show you that later. You can also grab text when you can also type text and press enter, but you have to save it in a variable. That's coming up soon. So press enter to continue. So when I do that, the next thing it does is it remembers these 3 variable values and pardon me, 4 variable values. And then it spits them back out with a print statement. Okay, next time I hit enter, what it's going to do is it's going to calculate the sum of A and B. So it looks to me like that's going to be 7. And then it's going to print C equals 7. Now we're moving on to a decide example. And again, these are examples from the chapter I just directed you to. And again, for those of you who are new to Python programming, it's a great place to start. So decide, it's saying if A is greater than B, then print one message, otherwise print another. Oh goodness, I'm sorry to hear that. Kate, hope everybody's okay, and I'll be sending you a link to the video recording, so don't worry, you won't miss anything. All right, so we're comparing A and B in this decide section. So A is 2 and B is 5. So it looks like B is greater than A, so it's going to print B is greater. And so it does. Now I want to point out that this is a very key part of Python, is that when you have something like a conditional or a loop, you have to go below and indented. So if A is greater than B, it's going to print A and is greater. Otherwise, if B is greater than A, below and indented, it will print B is greater. And then, of course, if they're equal, it'll print equal instead. And you can put more than one thing below there. So now, now these 2 things should be executed, but for some reason, I fouled it up. Well, does anybody see what I did wrong?
You missed the quote at the end. Print.
Oh, the end quote.
Yeah, just
Like
that.
so? Ah. So it's being so clever and filling in quotes for me. But now I have the end quote, and it's still saying there's an error. Missing closing bracket?
You're
Oh,
using
my
a single
goodness.
quote and an apostrophe.
Yeah, so
Aha.
you have 3 here.
This is very strange. Apostrophe. A single quote and okay. I'm going to just take this to test that idea. And we'll paste it in here. Okay. Oh, you're trying to
Yeah.
tell me that this apostrophe,
Yeah, we put a double quote on
yeah,
the
you would want to
ends.
have a double quote on the outside. Double quote. Okay. So that's coming up in strings. So now I can get away with the apostrophe inside. Boy, this autocomplete is sometimes more trouble than it's worth. All right, at any rate, so here we have indented two things below the below one of the conditionals. And so now we get to see that it will do both of them. And if I so this is, I'm just using this editor as a display, and then this one is the main editor. And so if I go through it now, we'll see that it should say really it's greater right here. Thanks for your help, folks. Then we have repetitions, and there's two important kinds of repetitions. One is a for loop, where we say for variable. And for those of you who are familiar with Python, you'll know that there's lots of really convenient ways to count, but I'm going to try to stick with the most basic, and that's what our tutorials do, where we have a starting value and an ending value that's one above where it really stops. So this part right here should count to 9. And again, this is all from the activities. And so you'll be hopefully typing it in and testing it out and modifying it and getting familiar with it, just like your students do. And then following that, we have an endless loop. So instead of for variable in range start 1 greater than finish, we have while true. And basically in range of this, when it'll go through and add 1 to n each time and check if it's in range. And if n is in this range, then it becomes true. And so it does what's below and indented. But if you just type true in there, there's no condition anymore. It just goes on forever. And so now we have the going on forever part. And so that's an admittedly super fast basics of Python scripting. Again, what you'll really want to do is go to the chapter and pay very close attention. I often ask, hey, is there a book I can get to teach me the basics of Python? Yeah, it's right here. It's the same one your students are going to be using. Okay, so in computer microbit talk, it goes a little bit further into the terminal, and so I would like to show you, or pardon me, into the serial monitor. And so what I would like to do is show you an example from computer microbit talk that that does a countdown application. So I mentioned that you could use the input statement to grab values from the terminal. Okay, and I want to paste this one to you. All right, and so when we run this one, what it does when we send to the microbit is it asks you the number of seconds to count down. And so I'll say 3 seconds, and then the message after countdown, and we'll say lift off. And then we can run it and see that it does all the things, which include communicate, remember, repeat, and actually we don't really have decide in, oh yeah, we have decide in a condition for the while loop here. We're saying while the value is greater than 0. So I'd like you all to try that and make sure it's working in your terminal. And one of the reasons I'm grabbing this one is I talked about it. This example was split into 2 microbits in radio data, and I mentioned that earlier on. So we'll actually be revisiting the countdown timer when we try out the radio data activity on Wednesday. See, and then we'll also be revisiting radio data in the cybersecurity, or this application, as one we protect with encryption in the cybersecurity attacks and defenses chapters. I forget which chapter. I'm assuming that it occurs in sniffing, and I can't remember if it also occurs in malformed packets. We'll see. Everybody got that one running? Okay, I see some nods, thumbs up. Okay, very good. All right, and feel free to give me a shout out if you just need a little extra time. This slide is actually a little old, but I'm going to just give you the link anyway, because it is another nice take on scripting. It has a little built-in tutorial. And so if we go to this page, so we have a little tutorial where it talks about Python, and then we have a little hello world and try out the buttons and play some music and, you know, detect movements. So there's lots of good little examples here. And then there's also another version of the API reference, and it'll tell you about the compass and its display and so on and so forth. So this one is just another take. Most of this is built into the editor now. So again, if you look in the left side panel, you have the API reference right here. And so that's probably a better, more convenient place to go if you want to find out statements to get certain things done. Okay, so here is the functions chapter, or pardon me, activity. And let's see here. I think we'll just do this one. Yeah, we'll start with smile and maybe just take a look at one of these others as well. So what this is showing is that you can create a function, which is a piece of reusable code, and we're naming this one smile. And then it displays the happy face for 2 seconds, and then it jumps back. And so I could say display dot show hello world. That was a smile. And the reason I added this is just to show that when it reaches smile, it goes and finds the function definition for smile, does that code, and then jumps back here. And then we could call smile again. And it would, so it would go, do smile, display the message, then go back, do smile again. And I just pasted that one into your chat. And this is one where it's occurring on the microbit. So here's the smile for 2 seconds. Then the message that I added to show that it comes back to the main part of the script. And then here's the smile again. So that's an introduction to functions. Functions are nice little reusable pieces of code. Here is one more function example. It's admittedly a bit dry. And what this one has is two functions. One is where it increases the value, and since we're trying to introduce it, we're trying to keep it very manageable in terms of what we're introducing. So we introduce calling a function, and now we're adding a parameter. So add one, you can start with a value, and so we're sending it 5, and so it should display the result of the call to add one, which will be 6 after it's done and comes back. And it's showing, okay, basically, when you call the add one function, it jumps up here with 5, and then it adds 1 to 5, and then returns the result, value equals value plus 1, so that's going to be 6. So this whole thing becomes 6. That's what it displays. And then it also has one where we add together, and this function has we use 2 arguments that are passed. 5 is passed to the value 1 parameter, 6 is passed to the value 2 parameter, and you'll be able to go through the tutorial and read more about this. And so this is again what it looks like. Oh, I saved it instead of sending it to the microbit. And so we want to see the value 6, and then we want to see the value 12 or 11, pardon me. Yeah, 5 plus 6. So that's another example of learning about the basics of functions, which is another Python programming staple. And then there's some nomenclature, and this is kind of a cheat sheet for that nomenclature. From microbit import star, you are importing what's called the microbit module. When it has a hashtag in front to the left of it, it's a comment. There's more about comments, how you can use 3 apostrophes or 3 quotation marks. I think you can even use 3 hashtag markers, and any of those will give you a multi-line comment. Then when you see display.scroll, display is the object and scroll is the method. And then hello world is an argument that's passed to it, its parameters. Then a function call is something like sleep, and then you have an argument that you pass to the sleep function. Image.heart is an object property that gets passed to display.show, and display.show is made to grab or to display pre-made images. So this is just a nice little cheat sheet that shows what some of the common, it shows how to refer to these different parts of the script. Lists and tuples. See if this makes it in. Yep, that looks good. Okay, so this one is going to be using the print, using print. I pasted it into you already. And lists and tuples are a way to essentially collect a group of values. And when we run it, it's going to display a whole lot of stuff pretty quickly. The first part is where it declares a bunch of data items between parentheses, and that's called a tuple in Python speak. And so this whole thing right here is, it's the same as a list, which is declared down here, with one exception. A tuple is something where you can't change it. In Python speak, it's called immutable. And so you can only check or get little pieces of the tuple. For example, you can print the whole thing, as we see right here. Or you can print one element. So tup of 2, 0, 1, 2. So if we're printing tup of 2, we're printing high. So there it is. And the same thing works with lists, except that you can actually say, instead of just saying, hey, I want an element of a tuple. Yeah, sure, you can say, hey, give me an element of the list, but you can also say an element of the list equals something different from what you started with. So instead of list of 2 being high, this right here changes list of 2 to being by. And that's why we see list of 2 equals by right there at the end. So those are lists and tuples. They're just collections of values. Back in the C or basic days, you might have thought of them as arrays. One nice thing, though, especially about lists, which is your editable version of an array, is that it doesn't restrict you to restoring one data type in a given array. Notice that there's an integer there, then there's a floating point, and then there's a string, and Python just takes all that with stride, which is really not in stride, which is really nice. Here's a nice application of lists. And what we'll need you to do for this one is go and grab this yourself, because it's too big to paste into the chat. So what you want to do is scroll all the way to the bottom of the page I'm going to paste in, and then you can copy it and paste. So copy and paste this into your Python editor. And if you have a microbit version 2, it will play music. Most of you will have version 2. There's a couple of you that might have version 1, and I apologize. It won't do very much interesting until you connect a speaker to with alligator clips, which it does have instructions in here on how to do that, I believe. Yeah, it shows which terminals on the edge connector to clip the alligator clips to that go to the speaker. But again, you probably won't need to do that. You can just play the music by copying and pasting this into your microbit editor, and then using send a microbit to flash the script. And then this notes list will be used by music.play. And the music will go on for a while, and you probably cannot hear mine because Zoom has some really fancy noise canceling that gets rid of electronic buzzing type instruments and their associated noise. But hopefully you'll be able to hear it on your end when you try it. Oh, impressive. My dog likes it. Yeah. Did he tip his head? Did he or she tip their heads? Oh, awesome. Okay, good then. So that is both how lists and tuples work, and then an example of passing a list to the music.play method. This is another one in lists and tuples where you can basically shake the microbit and then it'll pick out an activity for you to do next, which some students will appreciate. And as a parent, you could modify it to do your chores, do your homework, etc. All right, next up is the dictionary primer chapter. Dictionaries will become important because they are essentially the way that web browsers exchange information. When you do a search on Google, it gets turned into something called JSON data, or when you enter something into pretty much any field to send it to a server, it gets turned into JSON data, and the little container things are a bit different on the web, but inside the container is a name, or rather a key, and then a value. And so here for the shopping list, we have the key bananas, and we want to buy 3, and then the key bread, and there's one of those, 1 peanut butter, and 6 sodas. And so this is called a dictionary. And the nice thing about dictionaries, and it really becomes important when you have computers communicating with each other, is that basically you can send this list to another computer, and then that computer can say, okay, well, what's the value associated with peanut butter? And it gets the result 1. And what that does is it disassembles the old way that had been done in the past, where you're using a list or a tuple, and both computers would have to know that the third element is going to be the text value that it wants to grab. It's not a very productive way to get things done when you have computers talking to each other. Whereas our dictionaries, here we have names, Sir Lancelot, score 1000. And again, these are key value pairs. In between curly braces is the dictionary. And then you can also give each dictionary a name. And then you can basically say, oh, well, what is the score? Well, give me, so info is the name that was given to the dictionary. And so in your script, you can say, well, give me the value associated with the score key. Here's the score key. So this will jump and grab 1000 and then plop it into number. You can also, you can also, in a script, change the score. You can say info of score equals, and then a new value. And then it will go it'll find info, then find score, then change this 1000 to 1, 2, 3, 4. And so that is the idea of dictionaries, and this is what gets used in radio data. So we have a bunch of data that microbits send back and forth between each other. And I think I just want to, let's see here, create a dictionary. So this is billing itself as an interactive dictionary. Let's see how this works. Okay, so we enter our name, and then a game score, and then it creates a dictionary and populates it. So here it's creating an empty dictionary, and then it's populating it. And then it's going and grabbing the info and printing some results. So if we run this, I will paste it to you in a second. So if we run this, it'll say enter your name. So Andy, and enter your recent game score. I really did a good job. Oops, except for I hit the wrong button. Okay, Andy. My recent game score, 4 million. And then, so here's my name and my score. Andy used to be my handle as a video game player way back in the 80s. And so it's showing, it's basically able to create that dictionary, throw key value pairs into it, and then grab key value pairs back out of it. And then basically, again, here's a variable and it's storing the result of a key value pair. Here's another variable, it's storing another result, and then we just print it out. And you could, of course, just instead of name value, you could, of course, just throw info of name right there and forget about creating variables. But this breaks it up so that students can kind of look at it a little bit more closely and hopefully apprehend what's going on a little better because it's broken into smaller steps. And with that said, I'll go ahead and paste this in so you can try it out. And then it talks about changing dictionary values and expanding the dictionary. So lots of good stuff in there, which ends up getting used later in the cybersecurity part. So I'll give you a couple minutes just to run that and try it out. Make sure you've got it and feeling confident with it. Also, if you have any questions, chat it or unmute and shout it out. I guess I should point out that, let's see here, that in the script, we created an empty dictionary and then populated it with key value pairs. But another way to do it is to basically say, okay, here's the dictionary full of key value pairs, and we'll just give it a name. So you can pre-initialize like this at compile time, so to speak, or you can build a dictionary in runtime as is being done here. All right, and for those of you who are new to Python, you're probably well beyond saturation. Don't worry about it. That's why we have it all in chapters that you can go through and get familiar with it, because there's a lot of material to cover here. So so it's mainly we're skipping across the top. I'm trying to highlight just some important concepts that are introduced to the students. The next one I'd like to talk about is exception handling. This comes up a lot in cybersecurity, and you may recall, especially back in the 90s, it seemed like web pages would just freeze on us all constantly when you enter some kind of value into a field. The web page would freeze, and it was generally because the server did not have the script behind the web page did not have exception handling inside it. And so that's an example of where exception handling can cause troubles. Exception handling can also, lack thereof, can create vulnerabilities in scripts that can be exploited. So let's talk about exception handling and an example of a script that creates an exception. So I'll paste this one straight in. There we go. And we'll have you try that out. So this exception handling example is one where you'll have to rerun it each time you want to try it. It's not in a loop. And the first time through, running it unmodified, it divides 5 into 20, so it'll show us a nice quotient result of 4. So there was no exception there. Everything went as planned. But what do you think is going to happen if we change the denominator to 0? Does anybody see a potential problem computing that? I'm seeing some head nods. Yeah, so let's see what happens when we give it, I keep on saving it when I mean to send it to the microbit. Okay, so an exception occurred. And there's a divide by 0 error. Now, the important thing to keep in mind here, and I definitely encourage you to try that, is that it choked on line 12 and did not continue on to any of this other stuff. It just let the microbit system display this message saying that an exception occurred. Now, if you're in a robotics contest and a competing student is able to insert an exception into your radio-controlled robot by potentially sending the same data that you're trying to send to it, the robot will stop in its tracks if it does not have exception handling, and that could be a problem. And that's a good little microcosm of various automation vulnerabilities that can be exploited. So you could also probably divide by something like a text value, which also should not work. Whoopsie. And so both of those would be examples of exceptions. And the way that it is fixed is to try a line that you think might have an exception in it, and then do something about the exception. So if the exception occurs, we can print now. If an exception does not occur, we can use the else to do everything. And then maybe if we want to have a space at an end, there's even a finally category that will do something regardless of whether or not it's an exception. And I'll just change this to done so that we can see that it's done either way. So let's try it with the exception, and you'll notice that it does get all the way to done. And then try again would also probably fall in there. Okay. So it's not going to display the quotient if there's an exception. Otherwise, it'll say it'll just say exception, try again. Otherwise, it will, and just to emphasize this a little bit more interactive. So this is more or less what students are guided through. Slash is not supported. Oh, yes. Sorry for the delay here. Okay, so hopefully this works out. Otherwise, I might need you guys' help on troubleshooting this. Let's, I guess, run it first. Okay, division calculation, numerator 20, denominator 5, and everything worked out, and I get an answer of 4. So now we'll say numerator 20, denominator 0, and it says an exception occurred, try again, but it did not crash the entire application. It did not stop in its tracks, and that's a very important thing. So I want to have all you guys try this as a solution. There we go. So go ahead and try that for yourself. It's kind of nice to have an interactive version, and yeah, so that is the that is what we do later in the chapter. It's very close to this little piece of script right here. And it also goes into other little tricks you can do with exception handling, like find out more about the exception if it occurs. And then how to polish it a little bit so that it gives the user of the application helpful hints for common exceptions. And last but not least, we'll talk about strings, and then see, looks like I'm about out of time, so I think we'll pick up on strings and characters. I might just tack that to your homework to have you try strings and oh, heck, I forgot to have us plug in our second microbit and try it out. So let's I'm real sorry about this. Let's stay for a couple more minutes and let's all try to get our second microbit going. And then what I'll do is I'll send you a homework, and it's going to be basically to a couple of things to try with strings, and then to have an ongoing chat between two microbit modules over the radio. So those are two things that we're going to do. But what I want to do first is just try to get it so that we have 2 microbits connected. And so usually the best thing to do is to disconnect your existing microbit. So click the 3 dots at the bottom and click disconnect. So you can connect and disconnect. And once we have all our microbits disconnected, we can try plugging in that second one. And then hopefully when we try to connect again, it automatically stuck with the microbit that it was already connected to. But if we go over here and hit connect, it should give us two options. Now, the hard part is which one of these is the microbit that's already connected. And so one way to do this, to figure that out, is to basically unplug. No, sorry. So generally you can try just choosing one of them. What I want to show you first is that they usually have long serial numbers, but there should be an ending to the serial number that is somewhat unique. Like, notice that this is 3000 and this is 5000. So I'll just try grabbing the 5000 one and hitting connect. And then we'll try a script that shows which one is A and which one is B. So I'm going to send you a test script, display.show. And then we'll have one show an A and the other show a B.
We have a question on that.
Okay.
When you're looking at the numbers on those, it says, will the number always stay the same? Like, once I figure it out, I could label them.
That is correct. You can totally label them because the number will not change. It's a number that's burned into the microbits hardware. And so hopefully.
Is it the ID number that's listed in the left corner of the back?
Let me check.
Really tiny.
Yeah, let's see here. An ID number listed on the back.
Some of them
the
had
FCC ID number. Okay, so it's kind of hard to see, but right here, there's an FCC ID number in very tiny print just above the squiggle. And I do not see a similarity between that ID number and what's showing, though you might be right. Or there might be a way to figure that out. It might be a different part of the ID. And so right now, I loaded the script B and I have one microbit showing B. And then the other one, if I load it, either this B will change to an A. Yeah, so right now I have both microbits connected to the same, or I have both editors connected to the same microbit. And so generally for that, what you would do is right click the, do you see this little settings, the site information? What you can do is right click the site information and remove all the cookies and data. Actually, what I'll do is basically, see, where is it? I think what, okay, first I'm going to try removing all the microbits the computer has ever seen. And then it's going to ask me to reload. That is so weird. Not exactly sure why my okay, So now, after having clicked that little settings thing and removed any microbits that were connected, you can go ahead and hit connect again. And it'll give you the option. And so I'll choose 3000 here for microbit A. And then I'll go over here and hit connect. And then choose the one that ends in 5000 for microbit B. And, oh, great. I'm gonna load the script into microbit A just so I know which one it is. Okay, so now this one is microbit A. And I think what I'm gonna do is I've got a full, I may even have a video for you. And so because I waited until it was too late, because I forgot we were supposed to do this at the end of this session, what I'll do is I'll send this, I'll have you do this as homework, getting your microbit A and B connected. And it's usually not too difficult. I'll just try one more thing by unplugging both microbits.
Do have a question though.
Okay, go ahead.
Kelly says I only have one USB-C port. So can I only use one microbit at a time? Do I need a splitter of some sort?
Well, for example, I use this little splitter right here. Not all splitters are created equal, so this particular one works. Some don't work so great, but I would definitely try getting a little USB hub or splitter to so that you can get both connected to your computer at the same time. Okay, so this one ends in 3000. Send to microbit. Connect. This one ends in 5000. Connect. Send to microbit. Okay, so now I have my A microbit and my B microbit, and everything's ready to go. And it's always going to remember those settings until you unplug them. So I apologize for showing you all that stuff with the site settings here. All you have to do is unplug both microbits and then plug them back in, and it should allow you to then have one tab with microbit B and hit connect and choose one number, and then another tab with microbit A, hit connect and choose another number. And so that's the way it's supposed to work. And I'm sorry about the it's been a while since I've done this with 2 microbits on one computer. So sorry, I was a little bit rustier than I should have been. Again, I'll send you a full set of instructions on how to do this, and that will be your homework. And then we'll also try a little something from the strings chapter, and just have you maybe take a look at a few pages at just to see what kind of things are introduced there. And then we'll reconvene on Wednesday and start talking about how to get these 2 guys to talk to each other's radios and exchange data. See, would it be better to have them on 2 separate laptops? If you're able to attend this Zoom meeting on 2 separate laptops, that'll work out fine. I've noticed that attendees who have tried to use more than one laptop have encountered some challenges. But if you want to, I can set up a test meeting, and feel free to email me, and you can try having a second laptop if you're able to attend the Zoom meeting on the 2 separate laptops. It may take a second Zoom account. I'm not sure. If anybody has successfully attended a meeting with their same account on 2 laptops, go ahead and chime in now, because that would also be an option then.
We also have a question about the USB cables. It says, are the cables for the microbit C to C or C to USB? But aren't they micro B?
Yeah, it's A to micro B. So on the on this end right here, these are USB-A connectors. And then on this end right here, this is a micro B connection. It looks similar to a C connection, but there is a slight difference in shape, and the C and the A definitely neither will work in the others. You can't connect a micro B to a C or vice versa. Okay. All right. Well, thanks, everyone. We'll see you Wednesday. Keep an eye open on your email. I'll send a link to the video recording, a temporary one first, and then it'll go up to YouTube later. And then I'll also send homework instructions on how to set up your microbits so that you have two connected to two different microbit editor tabs. And then we'll proceed with radio networking on Wednesday. We'll look forward to seeing you then. And stick around if you want to do any offline questions or answers. We'll stop the recording now. Thanks for coming, everyone. Thanks for staying a little late. And we'll see you again on Wednesday.